Hello, and welcome to this lesson on the reactivity series. In today's lesson, we will understand why hydrogen and carbon are included in the reactivity series. So far, we've talked about the reactivity series, a powerful tool for explaining various chemical changes. You've become familiar with the order of metals based on their reactivity. Let's delve into why hydrogen and carbon, both nonmetals, are included in the reactivity series and how they are relevant. Hydrogen is included in the reactivity series for an important reason related to how metals react with acids. When metals react with acids, they typically produce a salt and release hydrogen gas. This reaction occurs because metals more reactive than hydrogen, which are higher up on the reactivity series, can displace hydrogen ions from the acid, leading to the formation of hydrogen gas. For example, when zinc reacts with hydrochloric acid, zinc chloride and hydrogen gas are formed. In this reaction, zinc is more reactive than hydrogen, so it displaces the hydrogen ions from the hydrochloric acid. Conversely, metals that are less reactive than hydrogen will not displace hydrogen ions from acids, and thus no reaction will occur. For example, when copper is added to hydrochloric acid, you will observe that there is no reaction. The copper remains unchanged and no hydrogen gas is produced. This is because copper is less reactive than hydrogen, so no reaction occurs because copper cannot displace hydrogen ions from the acid. Therefore, hydrogen's position in the reactivity series helps us predict and understand the outcomes of reactions between metals and acids. Carbon is included in the reactivity series because of its essential role in metal extractions, particularly its use as a reducing agent. Many metals are found in nature as metal oxides, and carbon can help extract these metals by removing the oxygen. This process is known as reduction, where carbon reduces the metal oxide to its pure metal form. The effectiveness of carbon as a reducing agent depends on the metal's reactivity. For example, carbon can reduce iron oxide to iron, as shown in this following reaction. Here, carbon is more reactive than iron. Thus, it can take away the oxygen from iron oxide to produce iron and carbon monoxide. However, carbon cannot be used to extract metals that are more reactive than itself. For example, aluminum is a highly reactive metal, and its oxide, aluminum oxide, cannot be reduced using carbon. Instead, a different process is needed to extract aluminium from its ore. Therefore, the position of carbon in the reactivity series helps determine which metals can be extracted from their ores using carbon. In today's lesson, we delved into why hydrogen and carbon are included in the reactivity series and their significance. Hydrogen is important in reactions of metals and acids. These reactions occur because more reactive metals can displace hydrogen from the acid. Carbon has a role in reducing metals. It can remove the oxygen from metal oxides found in nature. By including hydrogen and carbon in the reactivity series, we can better predict the outcomes of metal reactions with acids and understand the extraction processes used to obtain metals from their ores.